Signal processors are devices that allow the operator to alter an audio signal in terms of time, spectrum, or level. This lesson will focus on the different signal processing components and their functions. Signal processors are usually placed between the mixing console and the power amplifier in the signal path. There are two types of signal processors, analog and digital. Analog signal processors modify an incoming electrical waveform through adjustments made by the operator. Analog signal processors, otherwise known as outboard gear, are located outside of the mixing console and are mounted inside a rack enclosure. They typically include reverb units, compressors, limiters, and other types of dynamic processors. Digital signal processors use complex algorithms to edit the numeric data representing the audio signal in real time. Digital signal processing, or DSP, is a term for signal processing that combines complex algorithms and fast number-crunching digital hardware in order to achieve high performance and flexibility. Digital signal processors have become a new standard in the world of audio in the past 20 years. A single DSP can replace an entire rack of analog signal processors. A DSP has the potential to provide multiple processing functions, including equalization, compression, limiting, frequency crossover, and signal delay on multiple signal paths simultaneously. Digital signal processors are limited only by the amount of processing capacity within the processor chip. There are two subgroups in the realm of processors: effects processors and signal processors. Effects processors are those devices whose purpose is to artistically alter the audio signal. They are usually placed on independent channels or small groups of channels and not in the main signal path. Reverb units are the most common effects processors. Effects processors are typically found in the studio. They allow the operator to add artistic touches to their sound. Reverb units are used in live settings on both vocals and instruments to help create depth. Signal processors are devices commonly used to modify independent channels as well as the overall output signal. There are three main types of signal processors that alter the dynamic, frequency, and time properties of the audio signal. Each type of signal processor, whether it be a separate physical device or one of many virtual representations within a DSP, should all be thought of as individual processors. Dynamic processors affect the dynamic range of an audio signal without causing undue change in the perceived output volume. Within this category are compressors, limiters, noise gates, and expanders. A compressor is a signal processor used to reduce the dynamic range of the signal passing through it. Compressors are widely used to condense the dynamic range of an instrument or large group of instruments with a large dynamic range. Compressors have three main controls: threshold, ratio, and gain. The threshold control determines at what level the compressor begins compressing the signal. Once the audio signal exceeds the set threshold, the compressor activates. Only the portion of the signal that exceeds the threshold will be compressed. The ratio setting determines the amount of compression that will be applied to the signal. The ratio increases incrementally from 2:1 soft compression to 10:1 or higher, which is essentially a limiter. The input and output gain controls allow the user to compensate for any signal attenuation through the unit in order to maintain a consistent volume throughout the signal path. A limiter is a compressor with a fixed ratio of 10:1 or greater. Limiters also have an adjustable threshold control which allows the user to determine the point where the limiter activates. The limiter prevents the audio signal from exceeding the threshold. Limiters are used primarily to prevent the audio signal from clipping and overdriving the audio system. Noise gates allow signals that exceed the selected threshold to pass through at unity gain. Any portion of the signal that falls below the threshold is muted. A noise gate could be thought of as an automatic mute. When the signal falls below the selectable threshold, the noise gate closes or mutes the signal. A good example of this is on an electric guitar with several foot pedals. The guitar signals exceed the threshold and are allowed to pass through the gate. When the signal stops or falls below the threshold, the gate turns on, effectively eliminating any buzz or noise from the pedals. Frequency processors include equalizers, the most common signal processor. Equalizers consist of multiple filters and frequency-specific amplifiers that boost or attenuate particular frequency bands. They are used to modify tonal and timbral properties of an audio signal. The most common type of equalizers are graphic, sweepable, and parametric. Graphic equalizers are used to shape the overall spectrum of the signal. They are called graphic because the frequency response output resembles the position of the filter controllers, usually sliders in analog units. Each band of a graphic equalizer consists of a peaking filter with a predetermined center frequency and bandwidth. A parametric equalizer has the most precision of all types of equalizers. Parametric equalizers offer control over the three main parameters of the filter. These parameters are gain, center frequency, and bandwidth. A bandpass filter is a device that cuts both high and low frequencies and passes all frequencies in between. Bandpass filters are used primarily to focus on a particular range of frequencies or to remove lows and highs from the spectrum. A crossover is a device that separates the audio signal into two or more frequency ranges. Crossovers are commonly used to divide the high and low frequencies and route them to their respective loudspeaker drivers. Time processors affect the time placement of the signals as they are processed in the digital device. A delay processor is used to manipulate the time arrival between the acoustic signal from two loudspeakers at a common point in space. The arrival time can be tailored by delaying one of the two loudspeakers' signals in the processing path. Delay processors are commonly used to align the signal arrival of rear fill loudspeakers to coincide with the arrival of the main loudspeakers. Delaying the rear fill loudspeakers 6 to 12 milliseconds behind the main loudspeaker's arrival will trick the brain into thinking the sound is coming from the main loudspeakers rather than the rear fill loudspeaker. This technique keeps the listener's attention drawn to the front of the venue. The amount of delay applied to the signal can be adjusted by two increments of time, milliseconds and microseconds. 1 millisecond of adjustment roughly equates to 1 foot of distance and is used for coarse adjustment. Fine adjustments are accomplished with microseconds, which are most useful when aligning the drivers in a 2- or 3-way loudspeaker. Digital signal processors are available with a variety of input and output configurations. There are two types of I/O styles, fixed and configurable. Fixed I/O means that the number of inputs and outputs cannot be changed by the user. Configurable I/O means that the user can select the number of inputs and outputs via I/O modules or cards. The most common configuration includes 8 inputs and 8 outputs. Digital signal processors are based around two specific architectures, fixed or open. Fixed architecture is a term given to a DSP that has predetermined processing blocks and signal paths. The operator can select a pre-programmed signal path configuration and manipulate the various processing blocks contained within each signal path. Open architecture is a term given to a DSP that provides full freedom to the operator to insert any processor anywhere within a desired signal path. The number of processors the DSP will support is limited by the total amount of processing power within the unit. Open Architecture DSP provides an easy drag-and-drop process of building the system's processing section. Built into most digital signal processors is the ability to store and recall settings. Recalling equalization, compression limiter, and delay settings is as easy as pushing a button. This feature is most useful when controlling zones of loudspeakers in a venue that has multiple spaces and supports various functions. The continual influence of the computer networking world on the audio industry has produced IP-based digital signal processors. This allows the audio DSP to be placed on a computer network and function as a network device. IP-based DSP units feature monitor and control capability across the computer network and from remote locations by way of the Internet. This feature is very useful for updating the system or when remote troubleshooting is required. IP-based units can log events including failure, overheating, and system violations, and transmit error messages via email or a page through a network modem. Audio and DSP control signals can now be transmitted over a network using a single network cable. This is accomplished by sending an analog or digital audio signal into a network audio converter that converts the signal into data packets that can be routed over a network. Another network audio converter on the network converts the data packets back into an analog or digital signal, which can then be routed to an amplifier or powered loudspeaker. The future of DSP technology will provide seamless integration of device-specific processing incorporated into the digital device. Evidence of this is beginning to surface in newly developed powered loudspeakers, power amplifiers, and digital mixing consoles. Powered loudspeakers will have built-in equalization, delay, and limiting, all controllable via the network. Digital mixing consoles host all of the signal and effects processors needed to mix. Power amplifiers have crossovers, limiters, delay, and equalization built into the unit, which eliminates the need for external digital signal processors. DSP processing integrated into a powered loudspeaker allows the engineer to tune the loudspeaker to the room, alter the voicing, and easily change settings for different venues. Once installed, these loudspeakers will only need AC power and a network connection to transport the audio as well as the loudspeaker management control. Digital mixing consoles are more flexible and powerful than ever. The ability to assign multiple processing devices to individual channels, submixes, and the master outputs through an onboard DSP engine is made for more ergonomic sound reinforcement control. This amount of processing power built into the console is diminishing the need for outboard processors. Power amplifier technology continues to advance. Today's power amplifiers are capable of detecting shorted loudspeakers or cables and to automatically reduce their output to prevent thermal overloading or failure. With advancements in digital signal processing, power amplifiers can now host a DSP card that provides onboard loudspeaker processing. Additionally, power amplifiers can be controlled and monitored over a computer network from a remote location or over the Internet. Signal processors are devices that allow the operator to alter an audio signal's time, spectrum, or level. Signal processors include both analog and digital units. Analog processors are single-unit devices, where digital processors can incorporate multiple processors, adjustable via software. Effects processors are used to tailor a signal's artistic style, and signal processors are used for overall system adjustment and loudspeaker management. Dynamic processors are used to affect the dynamic range of a signal and include compressors, limiters, noise gates, and expanders. Frequency processors include equalizers and bandpass filters and are used for tuning the audio system. Time processors provide critical time alignment for systems with multiple loudspeakers as well as finite alignment between devices. The digital signal processor is paving the way for ease of operation, monitoring, and control of audio system devices.